This project started out to see if I could make a low-cost cat detector. So I gathered some components together which are quite inexpensive. This is a Bluetooth transceiver, cost about $5. This is a color sensor which cost a couple of dollars. This is a liquid crystal TFT display, color display, that cost $2 or $3. And this is an Arduino Pro Micro, which cost about $5. And you can see that most of the wires on the Pro Micro are used, most of the pins. Over here we have 3 passive infrared sensors like this. So these 3 are packaged so that they've got a little shield on them, which makes the thermal sensor fairly directional. The idea is that we can monitor not just that there is a cat, but which direction the cat is going. So if the cat passes this sensor before this one, then we know the cat is traveling from left to right. And if it triggers the right sensor before the left sensor, then we know the cat is traveling right to left. The sensor in the middle is going to be aimed up higher than the cat to detect humans, so that the human being doesn't trigger the cat sensor. So this is a system which not only monitors the presence of a cat, it can detect the direction of the cat, and this color sensor is actually going to be used to try and detect which cat. So we have 2 cats, one is dark, one is light brown, and we would like to know which one is going which direction, so maybe the color sensor can help us do that. And there's going to be some optics associated with this, but this section of the blog is just going to talk about the electronics a bit. So we have some software in there already, and what it's doing is it's showing you the red, green, and blue values that would go to the display here. And you can see that the thermal sensors are warming up. But basically this LCD takes a 16-bit value per pixel to give us color. The first 5 bits are red, the second 6 bits are green, and the last 5 bits are blue. But I'm only using 5 bits per color in this particular software. What I'm going to do with this rest of this display, this block of color down at the bottom, is the actual color that's represented by these red, green, and blue values. So when this first sensor gets triggered, there'll be a little red dot on the left side here. When the center sensor gets triggered, there'll be a red dot in the middle. And when the right sensor gets triggered, there'll be a little red dot on the right hand side. Now when either of these sensors gets triggered, it starts an event. And when the next sensor gets triggered, it will complete the event. So at the end, when the last sensor turns off, the event will be complete. And when it starts an event, there will be an E displayed here in the middle to represent the event starting. When the right to left event completes, there will be an L displayed on the left side of this display. And when a left to right event occurs, meaning the right sensor is the last one to go off, we'll see an R over on the right of the display. So if those sensors are warmed up, I can just do that. So if I show the right sensor, we got a red dot here and the event has started. And when I do the left sensor, we get a dot over here and the event is over. I don't know if hopefully the camera picked that up. I'm going to go the other direction now. So that's the left sensor, event has started, the right sensor, and it shows the right event has completed. Now there's also a color sensor here which will tack on a number which indicates which cat. And I think actually I'll just give them a different designation, different letter. Instead of left and right, I'll just give them a different letter so that I can just have to transmit one character on the Bluetooth to indicate that. But that's how it works. Now, just to show that it is pretty tough to get this thing to display red, green, and blue. So I've got some colored items here. If I put this blue cap on, you can see that that block goes blue, and it's showing that the blue value is 31, which is the maximum 5-bit blue display. If I pick up a red cap and put that on, we get a red block displayed, and of course the red value is 30, almost maximum there. I don't have a green cap, but I have this green piece of plastic which shows up as green, and it's just showing a value of 31 because I've limited the green to 5 bits as well. But we can get red, green, and blue. However, this sensor is pretty ornery, and it's tough to get it to show the color that you actually think it should be displaying. So we'll see how that works when I start putting the optics around this sensor. It's right now only going to measure color very close to the sensor. But I've got a telephoto lens, which is one of those lenses that you clip onto a cell phone. It's a really cheap lens. It costs about $1 or $2. And hopefully it will allow me to see colors at a distance. Since it's a telephoto lens, it'll bring the light from far away and expose it right onto the sensor. And there's a lot of mechanical design associated with this project so that these sensors are all positioned properly and all this electronics is in the right place. Now I just rigged it up using these DuPont jumpers, but once I put it into the chassis, these will all be wire wrapped just to see how that works. For now, we've got the software working to the point where it's sending Bluetooth with the color and the events that occur over there. And of course, if the middle sensor triggers, it means that a person has walked by, and it will not count that as a cat event. So that's a lockout on the event counter for cats. Now, it is possible, of course, for a cat to walk by at the same time as a person, but of course the person is going to know that the cat is there, and this device isn't really needed if you're right there with the cat. And of course, if the cat leaves the room, then of course the detector will detect that, and it will automatically resynchronize to wherever the cat is going. So stay tuned for the next episode, which will have probably all this wired up, and I'll show how it goes into the sort of complicated mechanical chassis.